Hey y'all, welcome to today's video on horizontal pod autoscaling. What are we going to do? Let's talk about the agenda. I want to start off by defining what a horizontal pod autoscaler is. Then we're going to run through a simple demo from the Kubernetes documentation. We're going to talk about applying this to a previous project deployment demo. So we're going to do that with how would we implement a horizontal pod autoscaler with Helm charts, and then how can we just add a simple manifest if we want to manage it that way. Let's jump to it. Now you might find yourself asking, what is a horizontal pod autoscaler? Great question. So glad you asked. Probably means you're here for the right reason. I'm going to go with the docs here. I'm just going to read some of this off. In Kubernetes, a horizontal pod autoscaler automatically updates a workload resource. So think deployment or stateful set. In our case, we're going to be doing deployment, with the aim of automatically scaling that workload to match the demand. Let's talk quickly about horizontal versus vertical scale. Horizontal scale is adding more resources, think more deployments, more pods. Vertical scale would be scaling a resource up, so giving more CPU to a pod. That's it, no need to get too much deeper. To simplify this, let's work under the assumption that you might want to scale up when you hit a certain percentage of CPU across the containers. For that, we could use average utilization for CPU. And spoiler, we are going to use the average utilization for CPU to scale up deployments. Let's see this thing in practice now. We're going to run through a tutorial on the doc. So we're going to start with something really simple, just get up and running and see how this works under the hood. You can see I went to the horizontal pod autoscaler walkthrough, and we're just going to follow this step by step. You're going to see before you begin, it asks that you have version 1.23 of Kubernetes. At present time recording this, the version is 1.2 something in Docker Desktop. So I want to find a way to use this so I can do the most recent update. You also can go through an older version. You can see the available documentation versions here. So you can go through, tweak that, go to an older one to match yours if you need to. So how are we going to do 1.23? We're going to use Minikube for this actually. So really similar to Docker Desktop. All right, so we have the installation instructions here. Minikube's a really great tool to also spin up local clusters. So think Docker Desktop, just a little bit different. Couple little nuances we can go through, but feel free to just follow the instructions to install here. I have my setup here. It's already actually installed, so sorry, we're not going to go through that. And then you could be off to the races with something as simple as Minikube start. That's going to go ahead and start a cluster. In our instance, we're going to want to specify a Kubernetes version, and I'm going to go into the docs and make sure we cover off how to do that. Should be down. You can see the other instructions here. So pause, stop, delete all if you want to get rid of it. But the Kubernetes version, that's a good one here. Equals v 1.23.0, and I'm going to start up a cluster with these instructions. We'll give it a second to go. I'll probably just sit here waiting. My computer sounds like it's trying to blast into space, so I can't wait to see what processes and how much CPU is being taken up. All right, let's see. Just check out pods all. And we see they are up and running. We have something set up here. We have a cluster that we can interact with, really similar to what we saw with the Docker Desktop setup, but with the right version of Kubernetes. Couple notes on other things to do some of the actions that we took in our previous tutorials. If you want to access a load balancer, Docker Desktop provides that out of the box, but Minikube, you would want to run Minikube tunnel to be able to access like that external load balancer, so whatever port is specified. So just note that if you're trying to like use this for a previous tutorial. And then we have a couple other ones that we will go through, but nothing crazy now. And all right, now that Minikube is up and running, we are ready to go with the tutorial. Let's go. All right, so we have the 1.23, and we are going to run and expose a PHP Apache server. Not really important, but basically what you want to know from this is that it's going to do some CPU intensive actions every time that it's hit, and it's going to echo OK. So we're going to see a bunch of OKs. It's going to hit us at a certain interval. We're going to use the one that they already have, so we don't need this. We're going to go through the deployment they have. So really similar to the deployments that we've seen in the past. You could see API version, deployment, metadata, the name of it, all the selectors, replica is going to be 1. The templates here, then the specs. So here's the important stuff, I guess. So the container, the name is PHP Apache. It's going to be pulling out this Horizontal Pod Autoscaler example. It's going to be port 80. And then this is what's important here. The requests. Each deployment is going to need to have resources specified. So what the resource is how much is being requested for each container. So this is CPU 200 for each container, and then we're defining how much. So defining how much we want to request, and then the limit. So once it hits this limit, that's when we want to start scaling up, and it can't go past that. So this is important. These are something we did. This is something we didn't do before. That you need to have these for the horizontal pod auto scaling. So if you want to actually learn more about this in particular, here's where you go. So Kubernetes docs, resource management for pods and containers, and you can learn more about what this all means. So the managing those resources for the pods. But really the TLDR, this is going to be important. We need this, and this is the thing to notice relative to what we've done before. Service, really straightforward. Selector, PHP Apache. The labels, metadata, all port 80, nothing really crazy or novel there. All right, so we're going to apply this without actually creating the deployment ourselves, but we're going to go and take a look. All right, so both of these are created. We saw that, it matches what we saw there. Now we're going to create the horizontal pod autoscaler. So the server is running, we see that we're going to auto-scale it. And we're going to create it here. See each pod request 200, average CPU, blah, 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 all fun stuff. But this is the important thing. So we're going to auto scale this deployment. So the deployment was named PHP Apache, as we noted. We're going to say the CPU percentage to auto scale on was 50%. And there's a min and a max. So how many deployments? So we'll see this all reflected. All right, so this deployment was auto-scaled. Awesome. So we can see, let's go take a look here. Target unknown. Now, what is that? All right, so when we are doing this locally, we don't have all the things set up. So what we actually need to do to make this work, there needs to be a metric server to be able to see what's actually happening. So there are ways to apply it, but in Minikube, it's really easy. There's a add-on that we can enable a metric server so we can have access to this information. Great, so we see that it's up and running, and probably give us a minute and we'll start seeing the target. But that's where that unknown is coming from. There needs to be the metric server enabled to be able to see what's going on. Let's see if it's up yet. Give it a second. I'm going to wait a second and let the metric server, probably about 60 seconds, and it'll be good to go. There it is. So we'll see the targets now at 0% of 50%. That's great. We'll see the min pods, the max pods. We saw how many replicas there are. We're at 1. That was what was set up here. Replicas. So the min is the 1. The max is going to be 10 for the pods. All right, so now we're seeing exactly what we expected here. Awesome, things we all set up. And we're going to start increasing the load and see what the scaling looks like. And we should expect to see OK Again, once it's hit, it sends us an OK response. Perfect. There we go. So it's going to start scaling up. Now let's go and watch this thing. We're going to start seeing a higher CPU load. We can also run that other command that we ran just to get HPA Autoscaler. We'll just run this. Wow, okay. 250% out of 50. All right, these are coming up now. Now let's see how this thing is scaling up. Now we have 4 replicas. Okay, so now we're jamming. Now it's scaling with us. You have these here. You can see this coming through. We get the pods. Just get all. And we can see these. So these are jamming. These are moving up. We are getting these in the last few seconds. So it's accommodating the scale. It's scaling up. We have set up a horizontal pod autoscaler. Let's get rid of the load. Now that we can stop, pretend like it's a spaceship. And then let's see how the deployment's scaling back down. Again, you can see it's going to take a bit of time. So this is not unexpected. All right, let's just follow along and we will see how quickly it changes. Now we're checking to make sure this thing is scaled down, and it is. So we went down from to 1, 1, 1. So up to date, available, and we're all set. I want to talk a bit more about what it looks like and what is happening. So let's run some of these commands and see what it actually created. You can see down here also that if we want to run, we can get the horizontal pod autoscaler, the one we want, put it in YAML, and then view this. So we're going to do that and take a peek. HPA Apache. We want the output as YAML, and then I'm going to pipe it into there it is, that. But I'm just going to actually get the output here, and we can maybe see if we take a look. So a lot of things. Now I'm going to run the piped output into all right, so we piped it in. This is about what I want to see. It should relate to it. We're getting rid of some of the status stuff. It doesn't really, we don't need to see all of this. I want to just cover off on the spec. So we see the max replicas over here, the min replicas. So those are all set up. So that's the scale that we just saw, the 1 and 10. We see the metrics, right? So this is a V2 auto scale. This is going to be something to note too, because some of the other ones are going to come up with beta, and we're going to change to the V2. Metrics, resource, we want to auto scale on CPU. Target is the average utilization I mentioned. Utilization, type resource. The order is going to be changed up a little bit, but again, it's YAML. It doesn't really matter the order here. Type is utilization, so we're just 50% utilization. We're scaling up. And then this is what we're looking at. So we're looking for the deployment, the PHP Apache. That's what we're scaling on. So we're monitoring that. We're looking at PHP Apache. We're deciding, following along. And then when it hits the average utilization at 50, we're scaling up to 10. So now that we've gone through this tutorial, seen some of the things, figured out how to actually see a horizontal pod autoscaler, we're going to go ahead and do this on our own. So add to some other pieces. So now I want to add this to one of our projects, but first we're going to go ahead and take that example and just apply it to some Helm charts to see how it works. And then I'll actually do a branch for horizontal pod autoscaling with Helm charts, and then the next piece that we're going to do. But I want to go through Helm. First thing we have to do is actually get the right Helm version, Because we're using Kubernetes version 1.23, note that you may need a different Helm version. You may have to upgrade. I'll make sure there's links in here, but just something to note in terms of support there for Helm. Let's go ahead, and I have the right Helm version created. So you can see I have the right Helm version. And we're going to go ahead and create a Helm repo, and we're going to take a look at what they send along by default, and then we'll go at how we're going to customize it. So Helm create, let's call it HPA demo. And it's created that. We're going to go ahead and look at the templates they give us. And we see they have a horizontal pod autoscaler set up here without anything from us. So let's see what they give us. All right, first thing I want to note is I mentioned that we're going to be using V2 previously. This is the V2 beta. So we're going to have to customize some things, and we'll go over what that might look like. But we'll see a lot of the horizontal pod pieces that we know and love that are going to be, we're going to adapt. So we'll see we have the metadata here. Helm sets all this up for us. Spec, so we have the scale target, so it's going to scale based on the deployment. All these things were things that we saw previously. Min replica, max replicas, things that we saw. Metrics, so these are the metrics that we want to scale on. This is going to change a bit, but you can see the CPU, and then you have the memory as well. And then where those set up, those are going to be in the values. So we'll see they set it up with Nginx to start, and then they have a couple pieces down here. So there's a resources, and there's an auto scaling that is set to false. So let's pull this up with one that I've already actually set up, and we will check it out side by side. We will start with the deployment. Let's go deployment. Okay, so I made this much simpler. We don't need all of these things for the deployments. Something here, you could probably customize this, but just for the purposes of the demo, I hard-coded these so it's easier to find. Let me see. So you can see the values.resources here. Let's go ahead and check those values files. That's going to be over here, and this one is going to be here. So let's go values. You can see that deployment had values.resources. So this was bringing in nothing because it's not going to auto scale. They don't recommend specifying these for good reasons, but for this demo purpose, we are going to do that. Going to do just that. But you see it's going to be a bit different over here. So this is going to be, again, hard-coded, but I could bring it in there. Limits, requests, all set up. So that's one thing that's different. But let's go from top to bottom and check out some of the differences here. Replica count, same. I have a name that I'm pulling in for some of the charts, not a huge deal. I brought in the HPA example here, tag latest. These are all going to be the same. These are all things that we don't need to pay attention to. And then we see I do have the resources set up for the demo purpose, and then the auto scaling enabled is set to true. That's a pretty big max replicas. We probably don't need that. This is going to be 50%. They have an 80 memory we don't need, but it would be the same process to implement memory versus this. Now let's check out the HPA. We're on the HPA. There's some slight nuance differences here, and I want to just point those out. And then we'll go into how you know about those and how you can make those types of changes on your own. So we see the really similar API version, but I have the V2 versus the V2 beta. So we're actually going to change something like this just to be V2. But then we want to be updated with the V2, so we'll go into that. Horizontal Pod Autoscaler, metadata, labels. We're not including here, but you very well could. You're scaling based on the deployment, min, max, all set up. Metrics, so slight differences. The beta used in target average utilization. This is using average utilization. Both type resource, defining the resource name. But how would you go about doing that? And again, we don't have memory. We're not using that, so we could, for both of these, really kind of block out the memory. But how would you know average utilization versus target average utilization? So what you do for something like that, you actually go to the Kubernetes docs. And this is something where, every time I see a config file, it's confusing. I'm like, how do they know to do that? These are all defined down here. So all the things that you wanted to know. So metrics, container resource, average utilization. So I could see that, this average utilization is the target value for the average across the pods. So that's going to be something really good to know, and you can start implementing that and looking at how it relates here. So good one to go see what's required, what's not required, what you want to do, and then find some kind of examples and kind of figure out how you might want to approach it. So docs here, really good example. Take a look based on what you want to do. So this is the autoscaling V2. So that relates here, but the V2 beta might be different, or is different rather. Okay, so that's all set up. That's the big difference there. The service is going to be the same. Pretty straightforward pieces. Let's go ahead and open up a terminal here, and we can see what it would actually look like to get this going. I do have a fresh cluster set up, so I'm actually going to go ahead and apply that here. I just checked. And this should install the Helm charts, and then I'll be good. It's good, all set up. Now it's running. Great. And let's scale this thing up. We can run the same things to actually scale. What was the command? Oh, it's create the... Sorry, I can't actually see with this video. This is unknown, so let's do the metric server added on. Okay, add-on has been enabled for the metric server. And let's see. Let's give that a minute to get set up. There we go. Metric server is enabled. We see the targets 0, 50%. We can scale it up doing the exact same thing. This is the same piece that we saw in the docs. We just made it Helm charts. So I customized that to do that. Again, these will be included in the repo that goes along with this at the HPA branch. So you can see kind of the changes and look a bit into it with some comments. This is working. I'm not going to scale it up because my computer is like crazy over CPU, and I don't want it to be too much of a background noise, so I'm going to scale this back down. And we're going to jump into how to do it with just a basic deployment. All right, y'all, we are in our deployment demo repository, and I'm going to go through just what's going on here. This is going to be in a horizontal pod autoscaling branch. It's currently on the last video's branch, but I'm going to make it pretty for you. These templates are going to live here. So now we're going to update the demo prod, which has the deployment and the service. We'll go over that. And then we're going to have the horizontal pod autoscaler. And we're also going to have Helm charts. I'm going to make a second Helm chart for HPA. So you're going to have the basic React app without it, and then you're going to have a Helm chart with the HPA set up in there. Let's run this. We're going to talk about the resources here. So again, this is something that needs to be specified if we want to actually do horizontal pod autoscaling. So you will have to update this. I will add in some comments for you. But again, resources, limits, necessary. We went through it. Need to add this here to make this actually work. And then we're going to the HPA YAML. And I want to clarify where this all came from. We're going to go from top to bottom and talk about it. So again, I'm in the Horizontal Pod Autoscaler docs, and I really just used this heavily to actually create this. Really use this heavily, so you can see the API version is set up here. So V2, the kind that just comes from down here. Metadata, pretty standard pieces. So standard object metadata, that's going to be standard across all the things that we create. And then the spec, this is where the majority of the work is going to be. And we're just following the instructions here. So again, we're setting the scale target ref, which is set up here. You have the API version kind name. Those are all down here. Those are, these two are required. We're doing deployment. Again, deployment, stateful set, something else you want to scale on. We're going to be using deployments for this. The name of it, min replicas, max replicas. Again, down here through those need to be set, and then metrics. So those are the big ones here. So we talked about this a bit. Metrics, the metric spec. So these are the big ones here. Metrics type, that's going to be required. The type is going to be resource, but you can see the examples. The resource then is going to be down here. Metrics.type down here, and then we're going to have how we're going to scale the resource. So name CPU, target, again, specified metric here. So we're scaling based on CPU. We're defining the resource. Target value of the specified metric is down here. So type.utilization, and then average utilization. Average utilization for the target there. And then we're all set. So hopefully that is useful. Again, this is going to be in the repository. And now hopefully you're off to set up some scaling mechanisms for your Kubernetes clusters. So horizontal scale to your heart's desire. Best of luck. Let me know if you have any other pieces in the comments. Hope this is helpful.